Something strange just happened in deep space. China, which led early tracking of the interstellar object 3I Atlas, suddenly stopped sharing any data right after its Mars flyby. No updates, no explanations, just silence. Why did the world's second-largest space power go dark on one of the rarest cosmic visitors ever detected? In this video, we'll uncover what really happened, why it matters, and what it means for the future of space science. When the mysterious object 3I Atlas was first detected in mid-2025, astronomers knew instantly that this wasn't just another comet. Its path was hyperbolic, meaning it came from far beyond our solar system. Only the third interstellar visitor ever discovered after 1I Oumuamua and 2I Borisov. China quickly joined the chase. The Purple Mountain Observatory, PMO, and the China National Space Administration's Deep Space Network, CNSA, confirmed its alien origin using combined optical and radar signatures, cross-checked by Japan's Subaru telescope and India's ARIES observatory. By late August, Chinese scientists released trajectory models predicting a near-Mars encounter. The Xinjiang 35-meter radio dish tracked the signal closely as it dimmed approaching its closest flyby in early September 2025. Then, silence. China's National Astronomical Data Center, NADC, stopped updating, and the entire dataset disappeared from public view. Reason 1: telescope scheduling conflicts. Official explanation: the CNSA said the halt was due to instrument scheduling conflicts. China's limited deep space tracking dishes had to be reassigned to higher priority missions: the Chang'e 7 lunar mission and the Queqiao 2 relay satellite calibration. Official telescope logs confirm this shift, making it the only publicly verified reason. It fits operational logic. The same antennas can't serve multiple missions at once. Reason 2: solar alignment and visibility limits. Around the same period, 3I Atlas passed behind the Sun relative to Earth. During such alignments, intense solar glare and radiation noise render deep space tracking nearly impossible. Most observatories, including NASA's, pause monitoring during these solar conjunction windows. This scientifically valid factor would have made continued tracking impractical even if instruments were free. Reason 3: equipment prioritization and maintenance cycles. China's deep space network possesses only a few large aperture antennas, 35 to 66 m. With Chang'e 7, Queqiao 2, and early Mars sample return rehearsals running simultaneously, operators likely had to reprioritize antenna time and perform calibration cycles. That would naturally push a non-mission object like 3I Atlas down the queue, an unspoken but logical operational constraint. Reason 4: data verification or reclassification delay. Another plausible factor is administrative. The NADC might have paused uploads pending verification of unusual readings. Because 3I Atlas was an interstellar object, engineers may have slowed public release to confirm data integrity through multi-stage quality checks. Such a pause would reflect bureaucracy, not secrecy. The global astronomy community immediately noticed China's silence. Loeb of Harvard warned, "Every lost observation narrows our window to understand what 3I Atlas really is." That warning captured the anxiety. Once the object passed behind the Sun, the opportunity might never return. Reason 5: signal overlap with defense frequencies. Chinese researchers speaking anonymously on domestic forums proposed that deep space radar signals overlapped with strategic communication bands, automatically triggering data classification. The Xi'an Satellite Control Center, managing both civilian and defense tracking, likely rerouted telemetry into secure channels. A similar event occurred in 2022 when data from asteroid 2022 WJ-1's atmospheric entry was withheld for the same reason. This explanation fits China's integrated civil-military network structure, a safety measure, not a cover-up. Reason 6: internal policy shift toward data sensitivity. Since 2024, China has strengthened rules on dual-use data, particularly radar readings that might reveal the sensitivity of its tracking systems. Under its civil-military fusion policy, information overlapping with defense operations can be restricted. 3I Atlas's unusual radar echo, brighter and broader than expected, could easily have been flagged as strategically sensitive, moving it into internal archives until reviewed. Reason 3: revisited. Bandwidth and prioritization. At the same time, China's limited network capacity had to serve ongoing lunar, Earth orbit, and Mars projects. Antennas supporting Queqiao 2 and Chang'e 7 require uninterrupted calibration sessions, leaving little bandwidth for transient deep space objects. This scheduling triage is consistent with how most national agencies manage scarce resources. Reason 4, revisited. Administrative delays. Some astronomers believe the NADC was simply overloaded. Processing terabytes of new data from lunar and relay missions may have slowed validation cycles for non-mission targets. In a data hierarchy dominated by flagship programs, 3I Atlas could have been unintentionally sidelined. By October 2025, discussion around 3I Atlas had shifted from observation to policy. The incident became a case study in how nations balance open research with strategic caution. Reason 6, revisited. National data classification policies. China's tightening control over deep space information reflects a wider global pattern. Under the civil, military fusion framework, radar or optical data that might expose the capabilities of national sensors are subject to review before release. 3I Atlas's interstellar signal likely tripped those safeguards. From Beijing's perspective, withholding such data is standard practice for protecting infrastructure integrity, not suppressing science. Reason 7, balancing science and sovereignty. Space discoveries have become soft power assets. The first nation to confirm or characterize a unique celestial visitor gains immense prestige. By pausing public data, China may have sought to avoid revealing the precision of its deep space radar network, data that could be reverse-engineered by foreign analysts to gauge sensitivity and range. This mirrors policies in other major powers, where disclosure levels are calibrated to protect national capability. Global response and cooperation. Even as China's feed went quiet, global science persevered. The European Southern Observatory, Gaia, and India's Institute of Astrophysics continued monitoring. Their data flowed into the Minor Planet Center, ensuring the world still had trajectory updates. This episode underscored both the resilience of international collaboration and its fragility when a key partner steps back. The bigger lesson. The 3I Atlas story proves that astronomy now operates within a strategic ecosystem. What begins as pure exploration can quickly intersect with national interest, infrastructure security, and data diplomacy. Whether China's silence stemmed from telescope conflicts, solar interference, bandwidth strain, verification delays, defense overlaps, or strategic discretion, it demonstrates one truth. In today's cosmos, information itself is power. When data disappears, so does certainty, reminding us that every observation we lose isn't just a gap in science, but a glimpse into how Earth manages knowledge that reaches beyond the stars. The mystery of 3I Atlas isn't just about a silent radio dish. It's a reflection of how space exploration has evolved into something much larger than science. China's tracking halt can be explained by telescope scheduling, solar interference, bandwidth strain, or internal data safeguards. But the deeper story is about how nations now treat knowledge as a strategic resource. Each missing data point reminds us that in the age of interstellar discovery, information is both a scientific tool and a symbol of national capability. The next time an object from beyond the stars visits, the world will need not only better telescopes, but stronger trust. If you enjoyed this video, don't forget to like, share, and subscribe for more updates. Thank you for watching, and see you next time.